Okay, so chapter 3, kind of going to be going into a different direction for a little bit. Today we're going to talk about functions. So there's kind of a few different things. They all work together. So you're going to see something, a word every now and again called a relation. And that pairs inputs and outputs. And really it's just a coordinate where x is our input and y is our output. Okay, so there's no stipulations to that. There's no like it has to be positive or negative, or they can't be the same number. Like it could be anything. Okay, now when we talk about a function, because not all relations are functions, when we talk about a function, it pairs each output with exactly, it pairs each input. I messed that up. It prepares each input with exactly one output. So here's the biggest thing. I'm going to write it really big. X numbers must be different. I'm going to write that in a different color. X numbers must be different. Okay, so you're gonna, almost all of your problems today, or a good number of them rather, are going to be just asking you, is something a function or not? So let's look at kind of a altogether version of this. So if we had -4, 3, 2, 6, 5, 3, 0, 8. Okay, is this a function? Okay, so here's the biggest question. Are the x numbers different? -4, 2, 5, and 0. They are all different, so yes, this is a function. Okay, now I want to point something out. We have a 3 here for the y number and a 3 here for the y number. Who cares? Okay, the y numbers don't matter in terms of that question of yes or no, is it a function? Okay, so you could see, or you will see, problems that are listed out as a set of points like that. You'll see some in what's called a mapping. So it's going to have it like this. You'll see input with an X and output with a Y. and it's going to list the numbers, and they usually go in order in terms like numerically, so it's a different order, but it's still the same numbers. Okay, so let's see, we've got a 3, a 6, and an 8. So notice on these ones, like there's 2 3s, they're circled in yellow, but I only wrote 1 3 here. So -4 goes to 3, 2 goes to 6, 5 goes to 3, and 0 goes to 8. Okay, so these coordinates up here is just being represented differently with this input and output. Okay, and notice each number only has one line going away from it. That means the x numbers are different. Okay, if there was, and I'm going to put something in, then I'm going to erase it. So if there was like a line going like that, you would see 2 lines going away from the -4, and that would make it not a function. Okay, so this is like 1 line each. Okay, so another way that the same problem, remember I'm going to write the same problem just in different formats, okay, is input x, output, I forgot the u. Is in a chart. So it's just creating the same situation, and you're still going to ask yourself, are the x numbers different? And so since we're representing each one differently, the answer is going to be yes for all of them, but you're still just looking at, are those different? Okay, and then lastly, if they were written on a graph, -4 3, 2, 1 2 3 4 5 6, 5 3, and 0 8. Okay, and so there's something called a vertical line test. Okay, so what does that test say? Each vertical line, so I can draw as many vertical lines as I want, but just each one individually, each vertical line can only touch the graph or point once. So the point ones are typically kind of easier, but there's a vertical line and I touch the point once. There's the vertical line and I touch the point once. There's the vertical line. There's a vertical line. So I only touched each point one time. Okay, so if there was like another point right here, the green one, well now this vertical line touches 2 points. And that would make it a no. Okay, so each one only touches one time, or one point, or one part of the graph. Okay, so you'll have some questions today where it's a list of points. You'll have some with this input output, what's called a mapping, where the lines go to each thing. You'll have some that are in a chart, like at the bottom. You'll have some that are on a graph. Okay, so an example, like going back to the vertical line test, because that one's kind of a good one. If we had a graph that looked like this, the vertical line touches 2 times, so this is not a function. Okay, if the x numbers were the same in any of the list of points, doesn't matter what the y numbers are. So if you had a graph like this, it's just a bunch of points, so we said, okay, vertical line, good, vertical line, touched 1, vertical line, touched 1, vertical line, oh, it touched 2 points. Okay, so if you put the coordinates down for this would be 3, -1, and this would be 3, -3, and those x numbers would be the same, not a function. Okay. All right. So a good portion of your assignment is just going to be function or not a function. Okay, so then we're going to have a few problems where it asks about domain and range. So domain are the x values, and the range are the y values. So it's going to be on a graph, are going to be these ones. So it's done 2 different ways depending on what the graph looks like. So let's look at 2 different graphs. So you might have a graph that just has points on it. Okay, and so you're just going to list the points. So you're going to have to figure out the coordinates. So this coordinate is 2, 1. This coordinate is -1, 2. And this coordinate is -3, -2. So you would say that the domain, and really the order doesn't matter. They tend to write them from smallest to biggest, but it really truly doesn't matter. So remember, the domain are the x numbers. So I'd have -3, -1, and 2 in some order. And then the range are the y numbers. So I have -2, 1, and 2. I wrote them smallest to biggest, but again, and it's okay that this 2 and 2 are in the ones in the domain and ones in the range. Like, that's okay. Okay. So if it's a list of if it's points on a graph, you're just listing out each one of them individually. So the more complicated one is if it's not a list of points, it's what's called a continuous graph. So if I went from like this point to this point here, and I want to pick a different one. Let's go way up here. Okay, so if it was like that, okay, what is the domain? So remember, the domain are x values. So it goes from here, you know, if I'm gonna go down like this. Okay, so the domain goes from here to here. So that would be -3 if I kind of drew the line up to the graph. And this one over here is 4. So -3, and we write this compound inequality. It just means between -3 and 4. And then I would do the same thing with the range is the y numbers. So as it goes up and down, so if I were to connect this all the way over, here's -2, and then it goes up to 1, 2, 3, 4 on that part also. Okay, so the range is -2 and 4. Alright, so you'll have a couple graphs where it's just points, and you'll have a couple graphs where it's continuous. So try to do like, where does it start and stop farthest to the left and farthest to the right? That'll be your domain. And then where does it start and stop from top to bottom? That'll be your range. Alright, so the last thing that you'll have will be independent and dependent variables. Okay, so in most problems, the independent variable are the x's and the dependent variables are the y's. Okay, so if we had this is from the book, but the function y equals -3x plus 12 represents the amount and it does say y, the amount y of juice remaining in a bottle after x, use the word gulps, or drinks. So independent and dependent. So if you had a bottle of juice or water or soda or whatever, that is sitting there, and I said you could take as many drinks of that as you want. That's independent. You have a choice. I could take one, I could take none, I could take three. Suppose you can't take an infinite amount of drinks because eventually like the liquid would be gone. But you have a choice in the matter. It's independent. I could take 2, I could take 5, I could take 20 small drinks, I could take, doesn't matter. You have a choice. Dependent is how much liquid is left in the bottle. How much liquid is left depends on your choice of how many drinks you're going to take. Okay? So in this example, the X, or the gulps, is the independent variable. And the Y, or how much liquid is left, is the dependent. Okay, so you'll have a question that asks that just it's a different scenario, but identify the independent and dependent variables. And then it's going to say the domain is, and in this case it's going to say 0, 1, 2, 3, 4. What is the range? Okay, well, that means I'm going to have to plug in those pieces of information. So if I have my function, and it said the domain 0, 1, 2, 3, 4, that means I have to plug in 0 so when I plugged in 0, I got 12. Plug in 1, I got 9. And I plug in 2, I get 6. When I plug in 3, I get 3, and when I plug in 4, I get 0. Okay, so you would get your, the domain is 12, 9, 6, 3, and 0. But I kind of also like to know, what does this really mean in this scenario? So if I had 0 gulps, there were 12 ounces. So that means the bottle was 12 ounces in all of it, if it was full. So after 1 gulp, there were 9 ounces. It's pretty big gulp, I think, to take 3 ounces. After 2 gulps, there were 6 ounces. 3 gulps, there were 3 ounces, and after 4 gulps, it would be empty. Okay, so 3 ounces per gulp. I think that's kind of a lot, to be honest, but that's okay. That's just what the situation said. Okay, so those will be the last 2 problems that you do. There'll be 2 different situations. Identify the independent dependent variable, and then if the domain is blank, what's the range? It'll give you some numbers. So okay, we'll kind of go through like all that. So we'll continue some more stuff with functions in a different way a little bit tomorrow. Okay, but go through the terminology here, knock out the assignment, and we'll see you tomorrow.